Hello. Okay. Hi everyone. So today Javier is going to tell us about the the SARA telescopes.
Okay. The idea of this presentation is to promote the use of SARA telescopes. SARA is a consortium of small universities in the U.S. and since the IAC has an agreement with the SARA consortium that allow them to use the JKT telescope that belongs to the IAC, and so the JKT is now part of the SARA network of telescopes, and this consortium controls or manages three small class telescopes. In the old times medium class, and the very old times big class telescopes. The larger is our old JKT, the 1 meter in La Palma at El Roque de los Muchachos, in a very good site, as we know, usually with a medium scene of about 1 arcsecond. The second largest telescope is the 0.9 meter in Kitt Peak. Also is an old telescope in the Kitt Peak Observatory. In fact, this telescope is the reconstruction of two old telescopes, two of the 90 telescopes in the mountain. They took pieces of both and reconstruct one of them for the network, and also a 60 centimeter telescope in Cerro Tololo, very good, also a very good site for astronomy with a scene of 1.3. Kitt Peak is not that good, but it's a rather good site. The medium scene is 2 arcsecond. There is a lot of program that can be done taking advantage of Kitt Peak, as we will see later. Let's talk about each one. The JKT is a 1 meter telescope in an equatorial mount. With the instrument is a 2K by 2K CCD imager that provides a field of view of 11.6 by 11.6 arc minutes and a Platy scale of 0.34 arcsecond per pixel. It's cooled up to -50 degrees Celsius. But using the Peltier system. The three cameras that we will see are all cooled. All the cameras in SARA are cooled by Peltier, non-nitrogen. So the idea is that you don't need people working at the telescope. The telescope are most of the time alone. That's why thermoelectric cooling is very good for this. We also have other very good cameras here. Those that use the IAC-80. IAC-80 is also cooled with a thermoelectric cooler. It's a similar camera, but this is not cooled too much. It's only to -50, and in our experience, even if the web page say that the dark current is very low, it's not negligible. You can have up to 50 ADUs in a 5-minute exposure. So if you need very accurate photometry, it's a good idea to take darks in the JKT. Also has a guide camera, but it is still not operative. Anyhow, you can do up to 5 minutes, not more than 5 minutes exposure times with the JKT with no guiding problems in general. From time to time you have some small oscillations, but it is very rare. I mean the image quality and the guiding is very good, as usual, as used to be with the JKT. So nothing changed in this sense. There is another instrumental port, but they still didn't. SARA still didn't decide what to do with. Right? In fact, they accept visitor instruments, but I don't think it is a good idea because There's nobody there. To install an instrument there requires people. So I don't know if it is a good idea now. But for a 1 meter telescope, I think that the CCD camera and imaging is the most productive way of using it. The available filters now are the Johnson filters, Johnson cousin, and the Sloan filters. There are no other filters now, but there is a space for more. This is a typical ACE filter wheel with two wheels and all this space for filters. So, and if I'm not wrong, it's a 2-inch by 2-inch filter. So it is typical. There is a lot of filters at the mountain that can be used. It's just to think in advance and ask and talk to Dan Batcheldor to see if it is possible to install filters in there if there is a program that requires it. This is a typical image obtained at the JKT. As usual, the quality is very good. The scene used to be below 1 arc seconds in several nights. In fact, I will show you some pretty pictures. Those pretty pictures that our Per Ablay, one of our support astronomers, M27 and M92, under very good seeing conditions. And also he has a competitor in the SARA consortium, that it is Bill Keel, that take also these wonderful kind of images, color filtering images with the telescope. So the telescope is doing very well. The camera is not fantastic, but it is good enough to do a lot of science with, as I will show you later. SARA Kitt Peak is a 90 centimeter telescope. Here you have the typical effective ratio, F ratio, there's the real diameter, 0.91, and has another 2K by 2K CCD that provides this field of view, is 16.8 by 16.8, with a larger pixel scale, that it is reasonable. If the scene used to be 2 arc seconds, you don't need to have a very, very high plate scale. Notice that this CCD is cooled up to minus 110 degrees. It's similar to the case of the IEC 80. So in this case, there is no dark current. I think that it is this CCD is a little bit better than the one you have at the JKT. In this case, you have much more filters, several narrow bands. If people want to use, the details are in the manual page, all the pass bands of the filters, and so on. So you can use H alpha and other narrow band filters there. And the other particularity of the Kitt Peak telescope is it has an echelle spectrograph, right, with a medium resolution, and the only constraint is that you can do only very bright stars. In fact, this is a combination of 3 exposures of 1 hour each of a 10.5 magnitude star, and they think that the more realistic limit to be able to observe something with this spectrograph is 11. Anyhow, up to now, only one observer from the IAC tried to use it and declined it after the first night. I will tell you later. The 60 centimeter telescope in Cerro Tololo, and the director is told Hewig. Usually the director is a key person because he's the person that is doing the local support, right? When you have some problems in the night or before start observing, and we cannot solve this by our support astronomer, people contact the director to see what's going on. Again, 2K by 2K CCD with this field of view and this pixel scale. Notice that it is again better than the case of Kitt Peak because the same conditions of Cerro Tololo are very good. And we have also here some H-alpha filters and the typical Johnson and Sloan broadband filters. Notice that in the case of Kitt Peak and Cerro Tololo, there's no possibility to put other kind of fixtures. So how you access the SARA telescopes? The SARA telescopes are controlled using Windows PC based systems, right? In the sense, for us, it's going to be a little bit strange to have a telescope controlled using Windows, because we know about Windows, all the bad things you can say about Windows are not enough. But this is the system that use the ECA, Astronomical Consultant and Equipment Inc., that is a company that provide that has made all the remotization system for the telescopes. It's a very interesting company. They refurbished a lot of old telescopes around the world, and also they have a very nice dome control system that is also used in SARA. So they control the telescope, the cameras, and the dome using AC software and Windows that works in Windows. And how you operate them? The idea is just to connect to the computers that do the operations, right? For this, there is some software that you can connect and control the computer as if you were there remotely. And the recommended one is the Radmin software that works in Windows, but we've been using also, and it's possible to use, Real VNC in Linux and VNC Viewer in Mac. Unfortunately, not for all telescopes. In the case of the Kitt Peak telescope, you can only use Radmin, right? For this reason, for example, I use my Mac, and then I have to run in parallel. I have a program that can make me a virtual machine in Windows, and I connect in Windows when I observe with Kitt Peak, right? And in the case of for the JKT and the Kitt Peak telescope, you can connect from wherever. You can connect from your house. You don't need nothing more than the software, right? That it is free available. So, but if you want to connect to Cerro Tololo, the system is below the network of the Cerro Tololo, and then you have to access using a VPN connection first. So this is also provided. We can provide the software and the passwords and so on to connect to the VPN of the Cerro Tololo. I will show some windows here, and then I will try to connect via VNC Viewer. I've been trying. The problem is that you will not see very well things in this screen, but just to show you that it is easy. This is the camera control of the JKT. You connect with the VNC and you can display the window is this PC window, you know, right? Is Windows, and then it's usually it's open. All the programs are controlled by the ACA. This is the ACA connector client, right? That opens several windows that control different things. Here you have a weather station that tell you the weather conditions, and if the weather is not good, you cannot open the telescope. It's not allowed. This DS9, probably all of you knows DS9. When you take images, the DS9s appear here, and the control of the camera. Then where you can select the exposure time, the name you can use for the images. This is something very particular. I think this is more based on the amateurs systems used everywhere. that the amateur choose the name they want to put to each image, and this is something that we are discussing, or I want to discuss in the SARA board, because it is not very professional-like. But at the end, you can put the name you want. For example, I used to put the date underscore the number of the image, or you can choose whatever other option, right? And you open another VNC window, and this is the telescope control computer full of windows. It's terrible. To be honest, it's terrible. Yeah, you have a window to open and close the dome, and you can change if you want by hand the azimuth, park it, or to send the telescope home. This is to position the telescope. Here you can introduce the coordinates of your object by hand, and the slew, and the telescope. If it's not out of limits, the telescope go to position. Here you can have another window to close or open the mirror covers. This is again the connector client. You can choose to open or close several of these windows here. These are windows that are related to know if things are going well or not. You have here like a path, you know, the old paths in the telescope. You can just move a little bit in north, south, east, west. Okay, you can do it here, or you can also click here and give offsets. And also here you can change filters, right? Just clicking in a filter, you can change filters. But also there is a possibility to make sequences of exposures, saying this filter, 6 exposures, that exposure time, next, this, blah, blah. Right? So it's like to be in the telescope. Also, you can change the focus. And one advantage of the CKT related to the other two, because this is the new ACS system, it's a beta release, fails a lot during the night. So usually you had to reset the system a few times during the night, right? It's a beta system, still not stable enough, but the advantage is that you have an automatic focus procedure that it is not in the old AC system that it is uses in the other telescopes. This is a zoom of the dome. This is the most important things. Open and close the dome. Just you click here and close the dome. It's like for amateur, right? Clicking and moving, nothing, no commands and things like that. So just a zoom of this part. And usually you have another PC that you can connect to see things like cameras, web cameras of the telescope to see what's going on, right? Here you have the JKT, you can see the peer, just in case something is in the way of the telescope. Nobody knows. Happened that people entered during the daytime at the JKT. Nobody and strange thing happened during this operation. For example, once the dome started to rotate alone in daytime, and when they send the ING person that it is. The SARA has a convention with the ING to send, if they need, they can send one of the technicians to see what's going on or change things and so on. The person that went there discovered that one cable, one Ethernet cable that connected dome with the system just disappeared. And then the dome started to rotate alone. So strange things happens in the observatory, phantoms or things like that. As I will show you, this is the old-fashioned ACE control system. This is the control system of the Kitt Peak telescope. So in this case, you put the coordinates here and go to the telescope. You have several buttons here to open the dome, close the dome, rotate the dome, put the dome in automatic mode, open the mirror covers, and so on. It's all operated from touching things here. And in my opinion, this looks much better than the other one. But you know, old people like me. So you can control from here everything. If the shutter is open, is closed, whatever. What happened with the covers, if the telescope is tracking or not, where is pointing the telescope, and so on. Here again, the filter wheel, the same system. You can change filter position. Here, change the focus and put some steps on the focus. As I said, you don't have an automatic procedure here, so you have to check, change, take an image, change a little bit, take an image until you see that the focus is good. Here you have a pad to move north, south, east, west, or northwest, by steps, just small offsets on the telescope. I mean, what you have in any telescope, you can control it from your computer, connecting this way. Well, again, a close visualization on this. You can enter a catalog here. I don't know how. I never do that, but probably one of our supporters can teach you how to enter a catalog of objects if you will observe several objects during the night. And then this is the camera control system of the in this case is the Cerro Tololo telescope, right? The images, when you take an image, the images are taken here. Sorry. Here is the window you use to take images, right? You can put the name, dark, a prefix of the image, and so on. And somewhere you can select the exposure time, the number of images, and can also do sequences of images here, right? And there is below this there is a button to start the sequence of images. And when you start the sequence of images, these images start to appear in this DS9. This is a DS9 window. You can see that the images are coming. And you can also use, this is the control for the guiding camera. You can use the guiding camera. I never used it. I don't know if our support astronomers have experience in using it. But this, for example, is the tracking control of the camera, the corrections that is introducing in Y and X, and this is for the guiding camera also. But in this window you can access in the telescope computer. You cannot access the images. To access the images, you have to go to the camera. Window, and in this case you can use one software that is typically used by amateurs, the Maxim DL. I don't know if you have ever used it, but it is useful if you need to make a little bit more on the images than you can make with the DS9, for example. Clicking on the images, you can get the full width of the scene. You can plot here. This is used to plot the star profile and things like that. For example, if you are doing focus, this helps you a lot. Let me try to make a connection with VNC. let's try to connect to the I'm trying to connect to, sorry. This is the window I'll show you. Unfortunately, I don't know why, but the resolution of the of the projector is awful, right? But here you have what I showed you previously. This is the window you use to point the telescope and change. Can be used to offsets. Also is what I use here. If you click here, you can introduce offsets, right? Instead of coordinated. If I click here, I open the dome, but I will not do that. In fact, I don't think I can because it is cloudy, right? It is cloudy, probably the humidity is very high. Sorry, I cannot see what the weather station say here. It's impossible, but probably the humidity is too high. In any case, when I observe, I also open the weather page of the observatory. I don't only believe in this weather station. Mirror covers again. You can open it. Okay. I can open the mirror covers. It's opening. And when I stop flashing, it's open. Okay. Now window cover is open. Window cover closed. You can send the telescope to zenith. It's already at zenith. I mean, all you need to operate the telescope is here. You can change filter. Let's say it's Johnson B. Okay. Be careful, don't have the Johnson B on one of the low and in the other wheel because it put both, right? I'm sorry, I don't see anything in this. So this is the way you can connect and control the telescope, and you can, let's say, connect to, let's say if it works, a few minutes ago it didn't. This is the connection to the, okay, it's connecting. Now, here you have the camera control. You can also change the filter from here if you want, right? Here you have a sequencer tool, open, or you can just take images using this. I have several ways of doing images here, right? This is to connect to the, it's very easy to connect to HKT, right? If we want to connect to CTIO, we have to okay. Well, I have to use the VPN. It's a connection, a VPN connection, right? Before doing anything, you need to be connected. Now I am connected. I can open the VNC. Once connected, I can open the VNC viewer and go for Magic. Wait. I need to in my computer I can see all the screen, not in the projector, I'm sorry. And probably when I move this to the projector, I don't see anything right again. So here we are in the telescope. We can do whatever we want on the telescope, right? What if somebody else is observing? You can interact with him, and this is one of the advantages.
This is what I was going to ask about, the scheduling and asking for time and so on. How does that work?
Scheduling. We select the proposal and I say the IAC has 30 nights at CKT, 12 nights at Cerro Tololo, and 12 nights at Kitt Peak per semester. Maybe this changed a little bit because another institution is entering the consortium, so because of they need funding. And then for example, now there is an open call. We make a rapid selection of the proposals. Fortunately, we don't have much pressure. In fact, we have to persecute people, saying, "Okay, we have night, please observe." And then we decide, okay, 5 nights in great time to this project, 3 nights night time, and so on, and send to a person that combine the 12 institutions and made a schedule. And usually, you go to the telescope as there is nobody there and then in your night there is a schedule on the web, but can happen that someone commit a mistake to be there. Happened, and that you go and encounter someone that is already taking bias and say, hey, and usually nothing happens. This is a group of small university teachers, mostly than researchers, and they work in an unstressed way, right? So people don't fight for time. Happens very often that the board we receive a mail, oh, tomorrow I can't observe because my grandfather is ill, so please someone else that can take the night. So it works in a very calm way, but this is the way it does. Okay. So it is easy. Two people can observe. People can be observing at the same time. This is interesting because if you have a group of people that you want to teach, for example, or you want to share nights to observe. In part of the night I observe this, and then you continue this, and so on, or you want to share nights in the following way, for example. Kitt Peak, for us is terrible because we usually start to observe at 1, 2 in the morning, right? And continue observing until midday. I share nights with David. David is a night person. His life starts at midday. So he starts the observations, and then I take the telescope at 7 in the morning and continue until midday. This is a fantastic way, and he observes at home and I observe at home. You can also open the VNC viewer and the Radmin only in a way that you can only display things, but depends on who observe it, who opened the VNC. Depends on me here. If I decide to just forbid me to touch anything on the telescope, okay, and nothing happens. Usually nothing happens. Maybe well, in the case of JKT, the connections are extremely fast. Nothing. I never see any problem of connections with the JKT. The Cerro Tololo is not that fast. Sometimes things go slowly, and Kitt Peak also is not that fast. But with JKT, it's like to be in the telescope, even at home. And also, if things are not that fast, you can change something here. For example, I'm not displaying the whole range of colors. I am limiting the. You can limit the the resolution and the color you want to have here. So, well, there are some ways of doing this. So you can, instead of displaying the whole range of color, you can display 8 bits, 16 bits. And this makes things go faster. Okay, so as we see, the control of the telescopes is very easy. It's straightforward. But even if you need help, the IAC provides support for observations. The IAC support astronomers provide support for the astronomers that want to observe in the IAC remote control room. In the old computer room is now a telescope remote control room, right? You have like 6 or 8 computers or 7 computers, don't know, with 4 screens each. Don't know if that helps, but sometimes I become crazy with these screens. But okay, you can display each of these windows. Remember, you need 3 windows. You can display one of each in each screen, and you can use the Firefox to attend the movies and so on during the observations. So if you observe in this room, people, you can have some support at least the first night by our team of support astronomers. But you can also observe from your house, right? Is what I do. I observe in my bed this way. So this is wonderful. If you think that I started observing with a photoelectric photometer in a telescope, in a 76 centimeters, or one of this class of telescope without dome, it's a roll-off, 10 degrees below zero in winter, and the whole night observing in the ocular of the photometer, to be in your house, in your bed, observing remotely is fantastic. So those that say that the old times are always better are wrong. Completely wrong. Okay. And also, our support astronomer can teach you in advance. You know, you cannot do all in daytime. Oh, sorry. You can do everything in daytime, right? One of the things that it is very bad, to be honest, are the manuals of the telescopes. Remember, this is used by a small group of people. Yes? Even at the IAC, the users are some 8, 9, maybe. But in the other institutions, usually we are a small group of 2 or 3 persons, 2 or 3 professors. So it's like their own telescope in the backyard, right? So they don't pay much attention in write good manuals. Don't need it. After 10 nights using the telescope, you don't need a manual. But for sure, our new users need a guide. So our support astronomer Pera and Joan Font are writing a guide to observe with JKT and with the other telescope. We hope that soon we are able to provide you with these guides, because in particular the troubleshooting is necessary. It's necessary, and in particular for the JKT. The other systems are rather stable. Yes, if something fails, usually fails the communications. But in the case of the JKT, the system needs to be restarted, and and sometimes you need to restart the computer. So there are some tricks that need to be well in black and white instead of just tell people, because we never remember all these tricks. So, great advantage of remote observing. We save money, we observe in a comfortable environment, nothing like my bed. Multiple observers at the different locations can share the telescope time. You can have a flexible scheduling and collaborative research programs. I mean, if people need to observe during 1 hour, it's easy. Just connect. You don't have to do the observation for them. They connect, do observations, and you continue. And I think that for educational programs, it's very interesting to teach our recent students, or for the faculty to do some observations with graded students. I think is something that we have to explore. Up to now, several astronomers of the IAC have been observing with the SARA telescopes. Those are the programs that got time. This is the only program that tried to use the spectrograph in Kitt Peak. They tried once. They find that the telescope is not enough for their proposals, so probably maybe this 11 magnitude is too optimistic. And also they find it is too difficult to center the object in the not the slit, the optical fiber. So they declined to observe. This is a new program by Borlaf et al. That are observing with Kitt Peak, getting the first experience. They still have no results. Pera is observing BA X-ray binaries. Roy is trying to do some eclipses of planets around white dwarfs. Jose Acosta is doing his optical follow-up of bright G-ray blazars. He's using a lot of telescopes, including SARA ones. Well, most of these programs use other small telescopes like the IC80 and so on. And we have 4 programs, we've been running 4 different programs to observe asteroids. That is becoming the most popular option for these telescopes at the moment. Pera sent me some of his preliminary results. I think that both nights were at Kitt Peak, the 29th of January and the 26th of February. The first night was it's awful. Look at the uncertainties in the colors, but he's taking, according to him, he's taking interesting data. This is of these binaries, X-ray binaries. This is one of the fields of one of the binaries. He measured all the magnitudes of the stars in the field, trying to look for these peculiar cases of objects with almost zero H alpha colors. I don't know why these are peculiar, why they are interesting. Ask Pera about, but it is very happy with the results. Roy is using the JKT and Kitt Peak telescopes to do the same kind of thing he's doing at the IC80. That means measuring eclipses of planets around cool white dwarfs. This is the kind of eclipse they are trying to measure. And this is one result, one light curve obtained with the JKT in 60 seconds exposure time with a RMS of 0.6%. So don't know, Roy, if this is good enough or not. I think so, for the kind of eclipse you want to see. Jose sent me this. Jose Acosta, all the fields he measured with Kitt Peak and JKT of his blasters, and now he stopped the program just because he has no manpower. So if someone offer. And as I say, the most popular things now are the asteroids. Look at this. This is one asteroid observed with the JKT, a very bright one, moving between the stars. What Stefan and myself are doing in these programs are light curves. That means we do differential photometry. For example, here you have absolute photometry of different stars with some variations at the beginning of the night, and you have the asteroid here and the difference between two stars with a very nice dispersion, only 4 millimagnitudes, which is very nice. And here you have the asteroid variation during this 2.5 hours. Here you have the following night at Cerro Tololo was awful, but look at the light curve, right? Differential photometry is interesting, and also the variations of the stars are very nice. This is Cerro Tololo. Cerro Tololo both. I will show you some of the JKT I did. I don't do dark current, and it works. But if you want to go very accurate, take care. In the case of Stefan program, they are combining observations at different observatories. The pink ones here are those obtained in Cerro Tololo, I think. And okay, Cerro Tololo and Cerro Tololo data combined with an observatory in Cordoba, don't know, somewhere in East Europe. You know that asteroids, when rotate, variate the brightness just because the surface reflect the light varies, right? And then you have maximums. Usually you have 2 maxima and 2 minima each rotation of the object. This is JKT, and in the JKT I did observations of objects much fainter. In fact, the object observed with the Cerro Tololo is 13.4. Here you have one object in 18.5 observed with the JKT. You can see the light curve is rather good. There's about 3 cents of a magnitude, 4 cents of a magnitude dispersion in differential photometry. Here you have 2 more examples. One object in 14.8 and another in 15.9 in the Cerro Tololo. Look, a small telescope, but if the object is bright, you can produce very nice light curves. And this is with SARA Kitt Peak with the 90 centimeter. And again, I go to fainter objects and I get very nice light curves of asteroids. This is almost a complete rotation of an asteroid. In this case, it's an asteroid in a cometary orbit. It's a kind of interesting object, but this is for another seminar. Okay. So finally, since January this year, we are taking advantage of SARA telescopes. Since April the JKT is operating and is doing fairly well, with needs improvements, but you can do a lot of things if you have the patience with the system. In the case of the JKT, to do it, comfortable, easy to use. And there are some other uses, for example, student training, that we need to explore, in particular with our PhD students and with the people in the faculty. Right? Hope that that this helps you to prepare proposal, and if you have any question.
Kitt Peak?
Kitt Peak you can guide at the moment.
Sorry, you can?
Guide
Guide.
at Kitt Peak. You can't in JKT. If you need to do a very deep single image, you can. But you can also co-add images with the JKT without problems. The JKT image quality is much better. Not only because of the observatory, because of the telescope.
Yeah, so the question was, if JKT has better seeing the telescope, why would you observe peak at JKT?
Well, it depends on your program. Depends on for example, one thing that can be done is to start observing with the JKT. You finish at 6, and then continue observing the same object with Kitt Peak. For example, it's something that can be scheduled. And also you have time. If you need a lot of time, and we have 12 nights at Kitt Peak, why use only the JKT? If you can retrieve this kind of light curve, why using only the JKT? Try also the Kitt Peak. I think that the Kitt Peak has a slightly better CCD. This compensates a little bit. The major difference is the site, for sure. In fact, during the board, the board was early September. The statistics of the 3 observatories were completely different. Since April, from April to August, the JKT observed most of the nights. The time the time they lost was mainly because of technical problems. There was a problem with the dome. One of them is the one I told you, but also they when you have a cut, electric cut, for example, someone need to restart the rack manually of the dome in the JKT. You can't do it. You can't do it remotely. So they plan to install soon a way to do it remotely, because happened once that the cut happened on Friday afternoon. On Monday we have a holiday, and they could nobody went to the telescope up to Tuesday, so they lost Friday, Saturday, Sunday, Monday, 4 days, just because of this, right?
Just for curiosity, the illumination of the mirrors in the JKT is done by the ANGI.
I don't know. Probably is done by.
Or general maintenance.
When needed.
Reflectivity.
I can imagine that if they need to do that, they will do it at the William Herschel.
Probably.
But I don't know. I don't think they re-illuminized the telescope. Oops, be careful.
Questions? Is that it? So let's Javier again.
Thank you. Write proposals, please, otherwise I have to